Alright, section 9.5. This will be your example video. And this is graphing and writing equations of hyperbolas. So, I know I kind of say this in every video, but remind yourself that on your exam, you will be asked to list important characteristics. So, all of those were listed on the last video, on the intro video, so if you didn't watch that, I'd go back, jot down those formulas and what the important characteristics are for a hyperbola, and I'm going to walk through a couple examples. Alright, so first one here says graph 36y squared minus 9x squared equals 324. Identify the vertices, foci, and asymptotes of the hyperbola. Now again, this line right here will not be on your exam. It's just going to say identify the important characteristics. You are responsible for knowing that those are important characteristics of a hyperbola. I'm going to also add on to that the center because that's an important characteristic. So, if you recall from the intro video, the formula for a hyperbola, I guess I'm going to point out a couple things. X and y should both be squared. It's always the difference between them. And it should always equal 1. So there's our red flag. It obviously does not equal 1. So I'm going to divide the whole equation by 324. So everything by 324. Obviously to make that equal 1. And simplifying that, you have y squared over 9 minus x squared over 36, and that's going to equal 1. So now you have a standard form equation for a hyperbola. And a couple of things you might want to note. You have to decide if it's going to be a horizontal or a vertical hyperbola. And y squared comes first. Remember, it doesn't matter which one is bigger here, like it did with an ellipse. So the y squared comes first, which tells you it's going to, your branches are going to be in the y direction. So it's going to be, you know, something like this and this. So hence I'm going to have a vertical hyperbola. So I'm just going to kind of mental note maybe up here. It's going to be a vertical hyperbola. And again, the reasoning is because the y squared comes before the x squared. So I am going to, I guess, start out with maybe figuring out what the center is, because that's usually the easiest thing to point out. So the center of my hyperbola, since there's no h and k, no shifting of my hyperbola, my center is going to be at 0, 0, at the origin. So I will go there in a second. Other things that are usually pretty easy to identify, provided the equation's set up for you, is your a squared and b squared. And remember that a squared always comes first. In a hyperbola, it's not always the biggest number, it just always comes first. So just remember that. So if a squared is 9, things I know is a is going to be 3. If b squared is 36, then I know b will be 6. I can also find c by using c squared equals a squared plus b squared. Again, hopefully you jotted down that formula. So c squared equals a squared plus b squared, and 9 plus 36 would be 45. And if I square root 45, let's see, 45 is 9 times 5, right? So c is going to equal plus or minus 3 root 5. And again, I square rooted 45, so square root of 9 is 3, square root of 5, square root of 5. Alright, so now what am I going to use all these pieces for? Well, my vertices, since I'm centered at the origin, I'm going to blow up my graph here for a second. Okay, I'm centered at the origin, and my vertices are going to be a units from my center. Okay, so a is 3, and I know I'm going the y direction. My vertices are going in the y direction, and it's going to go a units, which is 3. Okay, so I'm going to plot that first. So from my center, I'm going to go up 3 units and down 3 units. And I kind of know that my hyperbola branches are going to do this and this, but I don't know how wide or how narrow those are. Okay, so I'm going to start there. I also know that in the x direction, the asymptotes are going to go out 6 units because in the x direction, b squared is 36, which means b is 6. And that's not actually a part of my graph, but I'm going to plot those points, and I think you'll see why when I finish off the graph here. And I'll use a different color so that I don't 6, confuse that with my branches. Okay. So I'm actually going to list my vertices here before I go on. So my vertices are going to be 3 units above and below my center of 0. So it's going to be at 0, 3, and 0, -3, which you can see from the graph. And you don't have covertices with hyperbola, so do not list covertices. Foci are going to be C units from my center in the y direction. Foci always go in the same direction as the vertices. So C is 3 square root of 5. And think about just the square root of 45. That is, well, it's almost 7, right? So it's like probably 6.7-ish if you had to estimate that. And they're always inside your hyperbola branches, so that makes sense. So I'm going to list my foci also over here. I'm going to try to squeeze this all in around. So I got my vertices. My foci in the y direction are going to be at 3 root 5 and -3 root 5. And that's approximately 6.7-ish, and I'm going to also plot those. And I think I'll use red for that also. So close to 7, right? So very close to 7. So those are my foci right there. And again, my hyperbola branches are going to do this, and your foci will be captured inside, which should always happen, so you can kind of check your math as you go. And last but not least, I'm going to take my vertices and then my other points that are not covertices, and I'm just going to kind of make a little rectangular box here. With those. Okay, so I'm just kind of making a rectangular box here. This is not something you have to do, by the way. But then I can see that my asymptotes, and I'm going to use a different color, have to go through the center, okay, and the corners of these boxes. So I know that my asymptotes are going to be right here, and corner to corner of my box and through the center of my box. There we go. Now, what's really nice about the hyperbola is you do not have to test any points because I have my vertice right here, and I know I have my asymptotes, so I know that that branch, that hyperbola branch, will approach those asymptotes, so I don't need points to test. I just make sure that my branches approach the asymptote. Okay, so now my graph is actually done. So let me state that again. You know A is the distance from the center to your vertices. Your B value is the distance from your center to the other points, not called covertices. They're just extra points. That makes a nice rectangular region for you, and then you draw your asymptotes from the center to the corners of each of your boxes. From the center to each of the corners of your boxes, and that will give you an idea of the width of your hyperbola branches. Okay, now actually I'm going to keep my graph blown up for just a second. I want you to, you'll be asked to find your asymptotes. I want you to just take a peek here. It is very easy to see that from the origin, this asymptote right here has a rise of 1, 2, 3, and a run of 1, 2, 3, 4, 5, 6. So 3 over 6, of course, is 1/2. So this equation for this line, in fact, I'm just going to write it in here. The equation for this asymptote right here is going to be 1/2 x. Okay, the other asymptote, this one, starts at the origin, has a rise of 1, 2, 3, and a run of -1, 2, 3, 4, 5, 6, so 1/2, but it's negative. So this asymptote is going to be y equals -1/2 x. Very easy to pick out from your graph. Now, the other thing you can do is remind yourself that asymptotes are, if it's in the y direction, it's going to be plus or minus a over b times x. Well, my a is 3, my b is 6, right, from up here. So my asymptotes equals y. My asymptotes are going to be y equals plus or minus 3 over 6, which is 1/2 x. And done deal. Okay, this one is the reverse. Write an equation of a hyperbola with foci at -5 and 5, 0, and vertices at -4 and 4, 0. Now, I've sketched a graph of this already. Totally optional. You may or may not want to just kind of sketch a little sketch off the side. Not that you have to get as elaborate as that graph is. But things I would note, since my vertices and my foci are in the x direction, right, because they're both on the x-axis, I know that I'm going to have a horizontal hyperbola. Okay, you can also see that, of course, from the picture, but if you hadn't drawn out a picture, that would be your reasoning. So I know that my equation is going to be x squared first, always over a squared, and y, oops, not plus, sorry, it's a hyperbola, minus y squared over b squared, and then equals 1. So I have to figure out a, okay, well, from my picture, from the center of my hyperbola to my vertice, I can see that that's a distance of 4 units. It's scaled by 2's, by the way. If you don't have a picture, you can see that from my center, which is 0, 0. By the way, if you didn't have a picture, between -4 and +4 is 0. Between -5 and 5 is 0, so you know your center's at the origin. It's always the midpoint of your foci and your vertices. So 4 units from my center. So I know that A is 4. I know C, because my foci is always the distance from my center to that point, is 5 units long, because it's at -5 and +5, 0. So using C squared equals A squared plus B squared, I know A squared is 16, and I know C squared is 25, and 25 minus 16 equals B squared. So B squared is going to be 9. So I know what B squared is. I know A squared is 16, because A is 4, and that's all I need to write my equation. So actually I can, well, let's see, I'll scoot this up a tiny bit. Write out my equation. So x squared over A squared, which is 16, plus y squared over 9 equals 1. And there's the equation of that hyperbola. All right, last one, I'll go through this quickly because it's like the last one. Foci are at 0, -8, and +8. Vertices are at 0, plus or minus 5. So again, my vertices and my foci are in the y direction. So if you wanted to sketch a picture, you could. You don't have to. But at 8 and -8, I'm going to have my foci, and then at -5 and +5, I'm going to have my vertices. So it's obviously going to be a vertical hyperbola. So knowing that, I know that y squared is going to come first, and a squared always comes first in hyperbola. So again, vertices are the distance, and clearly it's centered at 0, the distance from the center to my vertices, which is going to be 5 units long. So A is 5. Foci, distance from my center to a focus point, is 8 units long, and that's always C. So again, using C squared equals A squared plus B squared, I can figure out, oops, if C is 8, C squared is 64, A is 5, so A squared is 25, and 64 minus 25 will give us B squared, which is 39. So I have B squared, and I know A, so A squared is going to be 25, and again, I have enough info to write my equation. So y squared over A squared plus, oh, not plus, I keep doing that, minus x squared over B squared equals 1, and there it is.